this was the last example we did yesterday, I believe. We created the 95% confidence interval for this. Your calculator can create confidence intervals for you. It is possible, sometimes the numbers are slightly different because we do have some rounding error involved, but I wanted to show you how to do that on here. So go to Stat, then go over to Tests, and if you go all the way down, you are going to the letter A. So you have to scroll down. Okay, it's got 1-proc Z interval. So go to A. Now, it has an X. In this problem, our X was the 272.
On an A? Like letter A, or there's an A over here?
No, get out of that. You go to Stat, Tests, go all the way down.
Or just click Test
to letter A. Okay, your X. Did everybody get into letter A? So now it should say X in C level calculate. So your X, we had 272. N was what? Your C level is your confidence level, which we wanted 95%, so 0.95.
Is that like the normal one that it keeps on there, or is that just the last one someone typed in?
I think that's what it does standard, but you can change it. Now you're going to hit enter to calculate, and it brings up this interval. We got 0.307 and 0.373
So that's
yesterday.
doing that formula.
This is the confidence interval it brings up. So we can compare, and we were pretty close. It tells you your p-hat in there was 0.34, which is what we were using yesterday. So your calculator can create these confidence intervals for you as well. You definitely have to be able to do them by hand, but good way to be able to check yourself. Okay. So
we always have to do them by hand?
On the test or quiz, you'll probably have to do them by hand because I'm probably not going to put a bunch of questions over the same thing on there. Okay, so let's look at this example. If I want to look at how the margin of error is affected by increasing my confidence level from 95% to 99%. So go back, let's just try it on the calculator. So go to Stat, Tests, A. My X is still 272, my N is still 800, but my C level, I now want 0.99. And I get a confidence interval this.
Wait, you told us to keep the...
This is our lower and upper.
Everything was the same except this is 0.99.
So the question was, how did the margin of error increase? Yesterday we found a margin of error of 0.033. How do I find the error in this?
Don't we make the little, like, the line and then put the upper and lower on there?
We can.
And then find the p-hat, and then however it's different from the p-hat.
Okay. So essentially this is our confidence interval. We knew our p-hat from yesterday, or it even tells you on here, what is your p-hat? So that's the middle. So to get your error, all you have to do is subtract. The error is just this distance right here. So the error is?
That's 0.431.
So what happened to the error? Did it go up or down? Yesterday's example, what was our error? 0.033, and now it's 0.043. So what happened is increasing the confidence interval increased the error, which gives us a wider interval. Which should make sense. If we want to be more confident, we have to allow more answers to fall in that range. So we have to make our interval get bigger, which makes our error grow. Questions there? So, the last thing I want to talk about, this slide, don't write this down right now, just follow along with me. So, if I wanted to estimate a proportion with a 3% margin of error and 95% confidence, what if I wanted to find out how many individuals should be in the sample? So I'm going to do a study, and I'm trying to pick out how many people I should include in my study. We know we have to have it large enough to get good data, but usually the more people you include, the more money it costs, so we don't want to spend a lot more than we have to do this study. So we need to be able to pick a good number. So this is a result of the formula. You don't have to necessarily write this down, but look at your formula sheet. We talked about yesterday, was that on our formula sheet? In your confidence interval, I told you that the margin of error was that thing you are adding or subtracting. So we had the p hat plus or minus, and then this represented our margin of error. The z alpha over 2 square root p hat times 1 minus p hat over n. I am trying to find my n here. So if I were trying to get n by itself, what would I have to do with my z? How do you get rid of a square root?
Square root.
Okay, so then I would multiply over my n, and I have to divide by that thing, which dividing by it is like multiplying by the reciprocal, right? So we're left with p hat times 1 minus p hat over, since I divide by this, it's just the reciprocal. That is the formula that we are going to write down in a second. So I'm going to put this on another slide, but I just wanted to show you, it just comes from the error formula if you solve this for n. Now the issue is, this formula, you have to know p hat to use this formula. And p hat is found using n, isn't it? So that's not all that useful. What we're going to do, we'll have two possibilities. Either we'll use the p hat, and again, if you don't want to write this part down yet, you can wait until the next couple slides and then we'll write that part down. So either we will have to use a p hat from a previous study or a pilot study. So if I'm trying to estimate the effect of some new online learning program and the effect on your grades in class, then I would have to have like an earlier version of the learning program and have results from it. Or we can let the p hat equal 0.5, which is going to give us the largest possible n we could have. If you just think about, normal curves, the largest thing happens in the middle. So that's like at our 0.5. And so that would give us the largest possibility. So what you need to write down, these are on your formula sheet. If you look in the chapter 9, over at sample size, we are looking at the first bullet there. So to estimate the population proportion, so this is the sample size needed to estimate our p. we can use this formula if we know a prior estimate. Let's write that one down. If we do not have a prior estimate, then we will go by this formula. You will always round up. So if I get like 130.1, I'm going to round that up to 131 because it's saying you would have to have more than 130 people. So always, always round up to the next integer, regardless of the decimal.
Why is it 0.25?
Because if you take 50% divided by 2, because we always do like the z alpha over 2. So let's look at this. Sociologist wants to determine the percentage of residents of America that only speak English at home. What sample size should be obtained if she wishes her estimate to be within 3 percentage points with 90% confidence, assuming she uses the estimate obtained from the census in 2000 of 82.4%. So, do we have a previous value? Yes. So we are using the first formula. So, formula is, excuse me, n equals the p hat, 1 minus p hat, z alpha over 2, divided by e squared. That's the formula we're going to use because I'm trying to find the number of people we need. So my p hat, that is my previous value, which is what?
0.824.
Okay. Now let's think about this z alpha over 2. 90% confidence interval. So my alpha would be 0.1. 0.1 divided by 2 is 0.05. So I have to look at z of 0.05. Now keep in mind what that means. That means that the area to the right is 0.05. So the area to the left is 0.95. So you are going to your normal table, looking inside the table.
For 0.05 or the 0.95?
Table gives you area to the left, so you have to find the 0.95 in your table and then tell me the z value.
1.645.
Okay. E is our error. What did it tell us about our error?
It's 3 percentage points.
Yeah, she wants to be within 3 percentage points, so my error would be 0.03. So then we just plug in. Put all of that in our calculator. So I got 436.04. So how many people does she have to survey? 437 people. We always round up. Did everybody get that? Part B. What if she doesn't use the census value?
Use the other one.
Okay, so this time if we are not using the p-value from a previous study, we are using the second formula. So that n is 0.25. Z alpha over 2 divided by E squared.
Was everything else the same?
So my Z alpha over 2 is still my Z of 0.05, which is still 1.645. My E is still 0.03, just like on the first one. And this time I get 751.67. So she doesn't use that earlier estimate. She has to survey 752.
So why did that change so much?
Because we
You wanna
are,
reach-
basically we picked this value for P that would give us the largest possible window. So that's where the 0.5 came in. So this way is always going to give you a larger sample.
If it doesn't have a
Yeah. Other questions?
But what answer do you want, like, on our homework? Do you want, like, the 751, or do you want, like...
You need to round up and tell me the number of people. Okay. Do we need to refresh how to do the confidence interval part from yesterday, or you guys think you can follow those formulas and do it? I would like one thing I want to talk about. If you would just open up your books, I want to do one sample problem with you.
Do you want that on our homework?
No, you can put this in your notes if you want. It's just going to help you with your homework.
What page?
431. Let's look at number 12. So 11, you're going to do 11 and 13 in this section, so I wanted to do 12 with you and make sure you guys understood exactly what it meant. So what they have done is told us the lower and upper bound. So if you think about your confidence interval, your lower bound is 0.051, your upper bound is 0.074. And we know that p hat has to be in the middle of this. That's what it is. It's halfway in the middle.
So you're just subtracting.
And so I am asking you to find three things on this. I want the p hat. I want the margin of error, which is E. And I want X, the number of people in the sample with the characteristic. So, let's see if we can reason through how to get this. P is the middle of this. How could I find the number in the middle?
So you subtract them and divide by 2.
No, dividing by 2 gives you E, doesn't it? No, that's the margin of error. So you just.
I mean, you add them up and then divide
Yeah,
by
it's
2.
like to find the number in the middle, you average, right? So we're going to add them up. Divide by 2. So I get 0.0625. Next question is the margin of error. There are several ways of doing this. The margin of error is the distance from P to one of those values. So tell me one option. Subtract. That would work. The 0.074 minus the 0.0625. I get 0.0115. Would I get the same thing if I did my p minus 0.051?
No.
Yeah, so it's the same distance. You could also just subtract these two and divide by 2, because it's half the distance between them. Okay. The third thing asks for my n, or sorry, s for x. The problem told us that n was 1,120. Keep in mind, p hat is x over n. That's on your formula sheet in the, it's under the chapter 8. P hat is x over n. We now know p hat from part A. So that equals x. N was given in the problem. So all you have to do, multiply by the 1,120, and x is 70. Okay, so this one's kind of working backwards. They gave you the confidence interval and wanted you to find all the previous pieces of information. Is that okay? So I'm done. You've got the rest of the hour tool.